Luc Brandts.
So, okay, so I'm going to be the one who's going to tell all about the disasters. So far we've heard all about the brain stories of things you can do, and we've heard how AI is going through the roof. We actually believe it's going through the roof, but nobody tells you when things go through the roof, you do have a hole in your roof. You do need to fix it. So I'm gonna talk a bit about the things we do, and maybe some of you know SRG, and if you know us about from the software guys. We are the people who know how to dig into software. We actually open up the black box that's called software. And that's what I'd like to call the birthday party syndrome. So as soon as you start to talk about software, people say, "Oh, can we talk about football? Like PSP winning yesterday on a great match, supposedly." So
Let me see. Where do I need to point?
yeah, thank you. That was not me clicking, but anyway, this is a bit the impressed by numbers slide. So there's a lot of systems that we monitor. We've been doing this for over 25 years, supporting all different technologies from the latest and greatest in AI to the COBOL stuff you probably have still running and everything in between. So this gave us a great view on how actually software compares and all the dots behind the different systems in our benchmark. And at the last part of the presentation, I will share a little bit more in the context of AI and also in the context of SFI. Another attempt for a click. Pressing the forward button. Yes, I am pressing the forward button. I guess I am. Okay, thank you. So why SIG and well, I put this thing aside then. And AI. So first of all, we'll be using it ourselves. We have a platform called Sigrid. There's some 40,000 rules in there that we've Gen AI enhanced. So explaining what the thing does or what you need to be doing, explaining how code works, even if it's some complicated codable stuff, explaining how architecture works. So we have a dedicated AI team ourselves. But more importantly, relevant for you is that we've analyzed hundreds of AI systems the last couple of years. We've been doing this for a long time. Personally, I've been involved, believe it or not, with neural networks in the 90s. I was a bit ahead of the curve, but still learned a lot back then. We've been the co-writer of the ISO 533A standard on AI engineering, meaning that we can explain you how to properly build it and have the proper governance around it. We have people in the Digital EU Act co-writing the part on AI insecurity, which is a very specific thing. I will touch on that in a second. We're a member of several standard setting bodies for Web, Sense, and ELIC, and et cetera, et cetera. And we do also readiness assessments and trying to explain and educate people on that stuff. Let's talk about AI. If you can go to the next slide. Why do we as people believe in AI? Well, there's a big promise in it. There's a technology belief that this is working. It's actually helpful. It's very, very nice. It suggests that some issues will be fixed, specifically on the Gen AI stuff. And there's obviously, and we saw some great examples earlier today, a lot of things that are working really well. So let's not deny, we are one of the people who really love what's going on. But we also need to understand what's going on. So on the next slide, you'll see, well, maybe this is based on how we grew up as human beings and on a level of trust where you have to rely on other people and other things. And therefore, also, since Gen AI specifically is so humanoid, it's easy to believe. But of course, there's also things that can go wrong. So if you move to the next. So this is a bit of a warning. So you see here a ChatGPT interaction with somebody is very politely saying please at the sentence and thank you after the answers being given. The reason for that is shown in the next slide. So when things go wrong, this is probably the people they will keep alive. So let's be careful there. So let's open up that AI assisted coding base. Let's open up that black box for a minute. This is going to be quite technical, but I won't be going into the program part too deep. There's a lot of programming happening with Copilot and other tools where programmers are being assisted with Gen AI, and it's working really well. On the next slide, you see that two examples, deliberately so small that you can't read it. But on the left, there's a bit of a of piece of code. This is actually things that have happened, so this is not made up, where a database being filled with data and something went wrong in this piece of code that they didn't detect immediately. It was also not found during testing, because when they had tests, they had 40 different servers running and everything went hunky-dory. They went live and poof, within seconds or minutes, everything went wrong because it turned out that different clients got the same ID. Well, you can imagine the mess that gives. And that's because there's no dynamics in there. The code looked perfectly well. And that's because Gen AI is dissociative. It's also not deterministic. So if you ask the same question twice, you might get a different answer, which also has an impact on the use case you're using it for. On the right, there's an example called package hallucination. And let me explain that in a bit for the non-technical people. 80% of all software that's run in the world is open source. Any developer uses open source. You are not developing everything yourself. You use packages, you lend things, and you reuse stuff. And when, therefore, Gen AI creates a piece of code, it also lends these packages. It just pulls them in. But you know the concept hallucination, I assume, where you get a question that is sort of right, but probably not completely. That also happens with the package. So that this particular package doesn't exist. So the code looks perfectly right, but the package doesn't exist. A hacker who knows this, and there's an example where somebody took advantage. Well, it was a white hacker, so he took advantage, but not really. It did this to show. And that package was downloaded hundreds of thousands of times to show how things can go wrong. So in coding, you have to review. There's CIOs and CTOs who allow certain applications not to be developed with Gen AI for this particular reason. Another application, they do allow it. So you need to be very specific on what you allow, what you don't allow. You need to have policies against that. That's something that really needs to be top of mind. Again, you don't need to understand the technicalities behind it, just that things can go horribly wrong. On the left, you have to spend a week to find that little error. That looks really nice, but was indeed a social project. Can go to the next. Let's look into AI systems. You're using AI systems. What could go wrong? So as you said, we're part of the standards setting bodies like OWASP. And the key thing in OWASP is shown on the next example, where here's a Jacob Turner applying for a job. And you see, was writing a nice letter to the skin, but there's something on here that's not immediately visible, but it is a problem. And that's at the top of the page, and we highlighted it on the next slide. So you see here, maybe if you click once more, this is called prompt injection. So you're using the knowledge that you have of the backend system. This is very common in normal software injection. So rather than filling in your name on the website, you fill in a database SQL statement and you get all of the data. This is something that security people are very well aware of. This is something new that you have to be aware of. So, and this is just one example of many, but you have to treat AI systems very differently from normal systems because it's a different way of interacting. So, and Jacob, I don't know whether he got hired or not, but maybe he got through. Let's go to the next. This is a complicated slide trying to explain the different things that you have to do to train a model. And typical security experts are focusing on the bottom part. There's input, there's an application, there's output. That's where all the network stuff is going on. But if you want to protect a new AI system, you have to look much broader than that. and there's like data poisoning and model poisoning going on. And these are very abstract things, certainly for non-technical people. So in my next example, I'm going to try to make that more clear of a data poisoning example, and also show you why this is not easy to solve and has a big impact. So look at this rather contentious picture. We're training, let's say, a neural network on to recognize planes as being friendly or foes. And we want to obviously protect ourselves against the enemies. So we want to be sure that when we detect something, we fire the rockets at the right objects. What happens if I'm able to poison the data? So, for instance, if you do one click, I pollute the data, poison the data by putting a big red dot in front of circling planes, friendly planes, and then declare them to be foes. This is something, once it's in the neural network, if you know how a neural network works, it's all weights and things, you can't detect this. It's not in the test data, so you won't be able to find it through testing. It's in the model, it's there, it's undetectable. Once this happens, and somebody, in this case a plane comes by with a big laser projector, you point a big red dot in front of the plane, that plane will be shot down. This is a very extreme example, but obviously you can understand that this is a very serious example. You can extrapolate that to your own situation. So the model and the data poisoning that can happen at all the different stages that I just showed needs to be protected. So if you look at an AI system, which is much broader than all of these steps before, security becomes more important. Because if you have the standard situation with standard software, you will be able to find even if there's a data breach or if there's a piece of software that's been corrupted, you will be able to find and point out that's where the back door is, that's where that problem is. You can't do that in case of a model, and you have to be upfront. And it's impossible to correct once that has gone wrong. Similarly, with if you're able to pollute the parameters, poison the parameters in the model, you can completely destroy the interaction with your clients, with the backend systems. So what I'm trying to say here is that it's all great, but there can be a hole in the open. Let's go to the next. I did say that we built, you saw this cloud of little dots. That's a benchmark that we every year we calibrate, and we show how systems compare. We have a 5-star ranking system where 3 stars is market average, 1 star is the worst 5%, and 5 stars is the best 5%. And then we typically see, and you saw on the little dots in the front, that the bigger the system is, the worse it gets. Very typical because they tend to be older, tend to be more legacy. Now let's look at how AI systems perform. On the next slide. The orange dots are the normal systems. The black dots are AI systems, data-driven systems. First of all, we see that the quality is appalling. It's at least half. Now, what does this mean? Is this a problem? Well, the difference between 2 and 4 stars is a factor 4 in development speed. What that means is that those systems at the bottom, if you want to do something to them next year, that will take 4 times more effort to make changes. And what's the reason behind this? Typically, AI systems are built by data engineers. Very clever people are figuring things out. And once it's working, okay, they go on to the next fantastically exciting stuff. But they're not software engineers. They don't build for the future. It's like you create a cartoon for the newspaper rather than creating the Mona Lisa that Leonardo da Vinci met within during his entire life and making changes to it and optimize. And the systems we're building are not systems for a week, a month, a year. They typically are a system that will last for 5 or 10 or longer. So we do see that AI systems need to grow. We also see that it's not a law of nature because there are several dots there on top. So you can properly build stuff. It's easy to compare. Any one of you has received a spreadsheet from a colleague where think, well, that's a cool thing. And let me use this. This is a nice graph in there. Let me try to change it. I have no idea what this is all about. What formula does it use? I throw it away, I rebuild it. That's what we see in those dots there. And there's a lot of costs. We're creating actually the legacy of tomorrow if we're not careful. So that's a big takeaway, to make sure to understand that AI is also software. It's not just the cool Gen AI stuff. There's a whole set of stuff around it. And for instance, we do a lot of due diligence projects where we look into typically some younger companies, a lot of cool stuff in there. Many of them have AI components. Some that claim it to be AI is maybe less AI than it is, but it increases the valuation. And when we look at the quality of those kind of systems, it's typically below market average because there is a lot of focus on building stuff quickly rather than building stuff for the long-term future. Now, you're obviously on banking, you don't do that. You're all built for the long-term future, but be careful, some of that future might be very long, and if you have a system that's below there, you're in for some very expensive years coming. Now, let's look, yeah, there's some explanatory text, I just need to link that. Let's go to the next. One other thing is the atrophy alert. And there's an interesting analogy that you can give, is nobody is doing a lot of math in their heads anymore, or some people do, because we all have calculators. So as a result, the skills of people calculating has gone down. Maybe not so much in the banking space, but in general, it really did. Now, there's something wrong with this analogy because a calculator actually gives you a very precise answer, and Gen AI doesn't. It gives you a very strong answer, but sometimes it needs reviewing. The calculator doesn't. It gives you the exact answer. It's a proper calculator. So you need to stay actively involved. So for instance, in coding, if you have people that only use Copilot to do coding, you'll have a problem because they can't review anymore. So junior programmers who will use it will become not more productive, but more dangerous. These are things you have to take into account because of this effect long term. So stay on top of things. Now, I'll leave you with one final remark. We are publishing a FSI benchmark. This is a preview where we show this is about an architecture, how architecture performs for systems that you want to get rid of, systems that you want to continue to develop, and how that compares to market average. There's examples in there on security, for instance, where we do see that, by the way, FSR security is significantly higher than others, but certainly not perfect. And on the next slide, it's my final slide, yeah, the QR code if you want to register for that report. I'll try to talk a bit longer so people can take a picture of this. Or we talk to one of my colleagues when we're at the stand later on. This is specifically on FSI. If you want to talk to us about how to get the software right or how to build proper AI systems, let us know. Thank you.
Well, they don't have registered.